Hi everyone, welcome to our class. Today I'm going to discuss mathematical reasoning. Mathematical reasoning uses logical and mathematical skills to determine the truth value of a given acceptable mathematical statement. It is used to get a conclusion based on relevant facts and sources that have been considered true. It is also used in solving problems. There are two common types of mathematical reasoning, the inductive reasoning and the deductive reasoning. Let us now differentiate the inductive and the deductive reasoning. In the inductive reasoning, we are given specific events or ideas. From the specific events, we try to look for pattern. And we assume that this pattern continues or is applicable to similar events. So based from the observed pattern, we make conjecture. The conjecture or generalization which is derived from inductive reasoning is considered only probable. And it only takes at least one counterexample to disprove the conjecture. While in deductive reasoning, we start with the laws or statements, a general statement which is considered to be true. And then we apply rigorous logical reasoning using known facts to arrive at a conclusion. And the conclusion obtained using the deductive reasoning is considered certain or true. Okay, let us now illustrate how a conjecture is derived using inductive reasoning. So here is an example. Myra is beautiful. Her sister is beautiful. With these two statements, what we can observe in here is that Myra and her sister are both beautiful. So in inductive reasoning, we can now make a generalization that all members of Myra's family are beautiful. Here's another example. Mina is using ball pen. Her seatmates are using ball pens. So we observe in here that Mina and her seatmates are using blue ball pens. And so our conclusion, we say that all students in the class are using blue ball pens. Okay, another example. The square of 2 is 4. The square of -3 is 9. And from these statements, we can observe that 2 is a real number and its square is positive. -3 is a real number and its square is a positive real number also. So we can make a generalization that the square of any real number is a positive real number. So it says that conjecture derived using the inductive reasoning are not always true. They are just probable statements, and we only need one counterexample to disprove that generalization. Okay, let us consider the third example, that the square of any real number is a positive real number derived from the given two statements that the square of 2 is 4 and the square of -3 is 9. Okay, let us consider in here 0. We know 0 is a real number. It is a real number, however, its square is equal to 0. We know that 0 is not a positive real number. So we have found a counterexample for the third statement that the square of any real number is a positive real number. So using the counterexample 0, we say that this statement is not true. So since 0 is not a positive real number, therefore the generalization where the square of any real number is a positive real number is not true. Here is another example. Use inductive reasoning to predict the next two terms in the sequence 5, 11, 18, and 26. So let us try to observe the given terms. So if we look at their difference, 5 and 11, we have 6. Difference between 18 and 11 is 7. difference between 26 and 18 is 8. Or we can observe in here that if 6 is added to 5, it gives us 11. 7 is added to 11, it gives us 18. 8 is added to 18, it gives us 26. Okay, so we have observed that the difference of the elements in the given sequence form a pattern of consecutive numbers. Therefore, the next term in the sequence is obtained by adding the next consecutive number in the difference, which is 9, to the last term, which is 26. So we have here 6, 7, 8. So the next term in the difference will now be 9. If we add 9 to 26, it will give us 35. And the next term is obtained by adding 10 to 35. So we add 10 to 35 to obtain 45. And so we say the next two terms in the given sequence are 35 and 45. Here is another example. Use inductive reasoning to predict the next two terms in the sequence 2, 4, 3, and 9. So if we are going to observe the given terms and considering their difference, we have now 4 minus 2 is 2, 3 minus 4 is negative 1, 9 minus 3 is 6. So as we look at their differences, it did not give us any observable pattern. And so therefore, maybe we can have another perspective in looking for the pattern followed by the given terms. So we have 2, 4, 3, and 9. If the first term is 2, notice that the second term, which is 4, is actually the square of 2. Then the next term is 3. It is followed by its square, which is 9. So we can observe in here that the first term is 2, the second term is 3. So they are consecutive counting numbers. And notice that the first term 2 is followed by its square. The third term 3 is followed by its square. So if we are going to summarize our observed pattern of the given terms in the sequence, we therefore have in here an alternate arrangement of the consecutive numbers 2, 3, the next will be 4, and it is followed by the square of 4, which is 16. And so therefore, the sequence may be formed as 2, 4, 3, 9. So we have 2 followed by its square, 3 followed by its square. The next consecutive number is 4, and it is followed by square 16. That is if we consider in here, we observe in here and consider 2 and 3 as consecutive counting numbers. However, there is also another observable pattern which is formed by 2 and 3. We can consider 2 and 3 as consecutive prime numbers. And following the same format illustrated in this example, we can therefore have the first term is followed by its square, the third term is followed by its square, and the next term should be the next prime number, which is 5. And so we therefore have the fifth term will be 5, and it is followed by its square, which is 25. And the sequence could have been 2, 4, 3, 9. So 2 followed by its square, 4, 3 followed by its square, 9. And considering 2 and 3 as consecutive prime numbers, the next prime number will be 5, and it is followed by its square. So here is another example. Use inductive reasoning to make a conjecture. We have here, think of a number. Multiply it by 9, then subtract 12. Divide the difference by 3 and add 4. Okay, following the process, let us try to consider any number. Let us say 9. Multiply it by 9, that would give us 81. Then subtract 12, that give us 69. Divide the difference by 3, so 69 divided by 3 will give us 23. and then add 4 will give us 27. So we started with 9, the result is 27. Okay, let us consider another number. Say 20. So if we multiply 20 by 9, that will give us 180. 180 minus 12 will give us 168. We divide 168 by 3, it will give us 56. And we add 4 to 56, that will give us 60. Okay, so we make our observation. When we started with 9, it gives us 27. We tried 20, the final answer is 60. Let us try another example, say 15. 15 times 9 is equal to 135. 135 minus 12 is 123. We divide 123 by 3, that will give us 41. And 41 plus 4 is 45. So here 9 resulted to 27, 20 resulted to 60, and 15 resulted to 45. So we can now make our observation that the original numbers 9, 20, and 15 following the process gives the result of 27, 60, and 45 respectively, where we can now make a generalization that the given process will result to a number which is equal to 3 times the original number. Okay? This time we are going to use deductive reasoning to make a generalization. Let us use the same problem that we just solved. Think of a number. Multiply it by 9, then subtract 12. Divide the difference by 3 and add 4. So our solution will start with, we let a variable represent any number. So we let that be represented by x. So take note of the difference between the inductive and deductive reasoning. In the inductive reasoning, we use a particular value, while in the deductive reasoning, we use a variable to represent any number. And then following the process, we now multiply the number represented by x by 9 and subtract 12. And then we divide the difference by 3 and add 4. So we have 9x minus 12 divided by 3 plus 4. And then when we simplify, take note, we use existing rules on how to simplify algebraic expressions. So we divide each term, 9x divided by 3, and you have in there negative 12 divided by 3, or 12 divided by 3. That will give us now 3x minus 4 plus 4. And then the final answer is 3x. So that means in here, if we follow the given process, an original number x will always result to 3 times the value of x. So the conclusion then will be, if 12 is subtracted from 9 times a number, and the difference is divided by 3, and then 4 is added to the quotient, the result will always be thrice the original number, as shown in our solution following the deductive reasoning. Let's have another example. Use inductive reasoning to make a conjecture. The process is, think of a 2-digit number. Reverse the digits, subtract the smaller number from the bigger number. So for inductive reasoning, we use a specific 2-digit number. Let us say we try 82. Its reverse is 28. So we have 82 minus 28. This is equal to 54. Let us try another number. Say 59. Its reverse is 95. So we subtract 95 minus 59. This will give us 36. Let us try 63. So 63 minus its reverse, which is 36. This will give us 27. Let us try another number. Say 53. So we have 53 minus its reverse, which is 35. This is equal to 18. Say 49. Its reverse is 94. So 94 minus 49 will give us 45. Then we try 26. Its reverse is 62 minus 26 will give us 36. Let us now make an observations of the tried number and the result when we follow the process. So when we start with 82, it gives us 54. 59 resulted to 36. 36 resulted to 27. 35 resulted to 18, 49 resulted to 45, while 26 resulted to 36. So maybe this time we can now see a pattern on the result of the given process. So we make a conjecture. The difference between any two-digit number and its reverse will always give us a number which is divisible by 9. Let us have this last example. Use deductive reasoning to make a generalization. This is the same problem that we just solved using inductive reasoning. So think of a two-digit number, reverse the digits, subtract the smaller number from the bigger number. So this time in deductive reasoning, we are going to let the two-digit number be represented by an expression. So since we have a two-digit number, that means we have a tens digit and a units digit. So together, we have the number will be represented by 10t plus u, where t is the tens digit and u is the units digit. The reverse digits of 10t plus u will now be 10u plus t. Okay, so we're going into the process, reverse the digits, then subtract the smaller number from the bigger number. That means we're going to get the difference between the original number 10t plus u and the reverse digits 10u plus t. So we subtract these two. And then we simplify. Since this quantity is preceded by a minus sign, we remove the grouping symbol by multiplying the distributive property of multiplication. That gives us now 10t plus u minus 10u minus t. And then collecting similar terms, that will give us now 10t minus t is 9t, u minus 10u is minus 9u. We have here two terms, and 9 is a common factor. We can factor that out. So starting from the assumed number or from the two-digit number represented by 10t plus u, then we get the reverse digits and then get their difference, we arrive at an answer 9 times t minus u. Or our generalization will be the difference between any two-digit number and its reverse digits is equal to 9 times the difference of the digits. Okay, we end up our discussion in here on the inductive and deductive reasoning. I hope you learned something. Thank you for watching.